Hello. Thank you for joining us at the Charge Virtual Conference on EV Engineering. I'm Chris Ruoff, the publisher of Charged. The topic of this session is how pressure-sensitive adhesives enable advanced thermal runaway barrier design. And it's brought to you by Avery Dennison. There'll be a Q&A session after the presentation, so click the Q&A button on your screen to submit your questions for our speakers at any time. And please welcome the host for this session, Scott Krasinski from Avery Dennison. Welcome.
Hello, everyone. I'm Scott Krasinski, Product Manager for Avery Dennison Performance Tapes for the automotive segment, and I'm excited to host today's session. Thank you for joining us today as we discuss how pressure-sensitive adhesives enable advanced thermal runaway barrier design for electric vehicle batteries. EV batteries are an area of expertise for our presenters today. First, we welcome Michael Van Herentz, Automotive Business Development Manager for Avery Dennison Performance Tapes. Michael will share us the benefits of pressure-sensitive adhesives and how these benefits support EV battery pack safety, including thermal runaway prevention. Next, we welcome Mike Sanders, Senior. Mike will be sharing insights and data behind EV battery safety and growth. Our final guest is Melissa Widener, Global Growth Manager for the battery group with Alcogen, a specialty materials manufacturer focused on battery technologies. She'll detail the thermal and electrical barrier constructions along with engineering behind battery pack development, including the pack construction specific to the mitigation of thermal runaway. Thank you to our guest presenters. And with that, let's review quickly how we will work together within the battery pack value chain. The EV battery supply chain can be quite complex. There are varying degrees of vertical integration from cell manufacturers to OEMs. And to oversimplify the process here, electric vehicles begin with the production of the battery cells. These cells are then assembled into a module, and then multiple modules are assembled into a pack. And finally, the pack is assembled onto the vehicle. Alcogen and Avery Dennison's products are often laminated and die cut together to enter various points along the supply chain. And Alcogen and Avery Dennison work with cell manufacturers, tier 1 suppliers, and OEMs and converters to offer solutions for this market segment. Many of the applications we are discussing today will enter at the module or the pack assembly level. So let's take a look at today's agenda. First, Mike Sanders will lead off with trends for battery pack manufacturing and their implications for pack design. Mike Van Herentz will introduce pressure-sensitive adhesives, discuss their overall advantages in EV battery pack design, and look at how they can help solve challenges related to thermal runaway. Melissa will then will tell us how Alcogen offers solutions for thermal and electrical barriers for EV battery packs and how these solutions utilize pressure-sensitive adhesives. And then finally, Mike Sanders will return to provide a perspective on the EV battery markets. And we will end with a Q&A session at the end. So with that, let's hear from Mike Sanders on where the battery pack is going.
Thank you, Scott. Looking forward to giving people a view of where the battery pack market is going. The battery pack market has changed very dramatically in the last 10 years, now with OEMs doing most of their own pack building. The value chain remains very mixed for non-large automotive applications. Specialty applications are also driving integration and custom systems to another level. And we're seeing those smaller pack applications also have a much higher pricing structure. Regulations in China are setting the standards for egress, and we're also seeing the EU now following forward with notification type systems being required. Substantial program launches are going to show the first major launches of safety materials into vehicles, and that's likely to set the standards as we go into the next round of pack builds. As we look at the packs themselves, the packs have changed fairly dramatically. And what you can see here is a prismatic a pouch and a cylindrical cell, all heading towards structural elements in the vehicle. What that's going to do is really limit the space that's available for materials and materials integration into the battery pack. As we look at where this is going to go over time, we're projecting at this point that the cylindrical will remain at about 18%, prismatic will grow to about 42%, and pouch will fall to 38%, but all basically remaining about the same as they are today. As we look at the risks that we're still facing in battery packs, we see we're continuing to learn regarding fire safety and what's going to be required to basically manage the risk to occupants, to the vehicle, to charging. Many are touting that LFP is the answer for the safety situation, but we're seeing significant challenges in LFP in charging fires, in issues still in transportation. So we are pretty comfortable in saying LFP is not the whole answer. Systems are going to have to change inside the battery pack. Overall systems management will have to continue to improve and upgrade. And we're going to continue to see more designs on fire safety as we continue to move forward. First responders and firefighters are also learning how to deal with electric vehicle fires. And this is also likely to impact the overall design changes as we go into the next round of vehicles.
All right, thank you, Mike. Now let's move on to Mike Van Herent as he walks us through pressure-sensitive adhesives and their role in thermal runaway mitigation.
Thanks, Scott. The Avery Dennison EV battery portfolio includes a range of functional bonding and protection tapes built on multiple pressure-sensitive adhesive technologies. These solutions are engineered to make EV batteries safer, more efficient, and easy to assemble. Our pressure-sensitive adhesive tapes complement many of the battery pack thermal, electrical, and bonding solutions that addresses the challenges that Mike Sanders just told us about. As you see from the graphic, Avery Dennison has many different applications within battery assembly, but today we're only going to focus on thermal runaway and fire retardancy. Let's take a minute and look at the technology behind pressure-sensitive adhesive tapes and how they work. So a traditional tape consists of a pressure-sensitive adhesive, also known as a PSA in the industry, and a film that combine to form a tape. That pressure-sensitive adhesive forms a bond with the material after contact when a light pressure is applied. That pressure aids in the two primary reasons why a tape sticks. First is bonding adhesion. That's the flow of adhesive into the surface, and it's based both on surface energy and intermolecular forces, things like interlocking, chemical bonds, and van der Waals attractive forces. You may remember some of these from your high school chemistry class. The second reason a tape sticks is when a force or load is applied to that tape. The high viscosity of the tape occurs when a force or load is applied to the tape. That high viscosity of the adhesive allows elongation, absorbing energy, and allowing it to hold in place. These adhesives are laminated to functional materials, such as thermal runaway papers or films. Functional materials use PSAs because they offer a wide range of benefits for battery packs. These are things like elimination of fasteners, uniform coverage, lower no tooling, CapEx cost, investment costs, slim thickness profiles, no cure time allowing for high productivity, and durability to last the life of the vehicle. So for these electric vehicle battery applications, Avery Dennison has 3 PSA families used in this portfolio. The selection of the PSA depends on the customer performance requirements. Avery Dennison's flame tough acrylic and silicone adhesives are recommended when UL94V0 or VTM0 flame retardancy is required, while the general automotive acrylics meet standard flame performance of FMVSS 302 burn requirements traditionally used in automotive requirements today. We combine these PSAs with thermal runaway films, primarily being polyester or PET for surface protection and dielectric insulative performance. Our flame tough polyester, which is a vertically integrated Avery Dennison film, offering both VTM zero flame retardancy and dielectric protection. And then flame tough polyamide, which offers extreme surface temperature performance and both VTM zero flame retardancy and dielectric protection. We primarily use this in extreme applications like aerospace. I'll briefly touch on a couple tape constructions shown in the lower left hand also. The first is single-coated tapes. These only have adhesive on one side. You can think of something like a packaging tape that you use around your house. They're used more for protection than they are for bonding. The second is a double-coated tape. These have adhesives on both sides of carrier film. They're primarily used when bonding materials together, with the added benefit of the carrier film providing additional flame protection and dielectric protection. Avery Dennison currently has 23 products in our EV battery portfolio, with additional products being developed based on the feedback from the industry. Now from the customer's perspective, we know OEMs are focused on multiple issues, including safety, production efficiency, durability, sustainability, and functionality. We refer to these as their pain points. So how do PSA tapes address these pain points? Well, safety is addressed through the properties that reduce flammability and increase dielectric strength. This in turn leads to greater protection of the vehicle occupants in the event of an impact. Unlike other types of adhesives, PSAs don't require curing time. This helps increase the production efficiency of the product. To improve durability, PSA tapes encapsulate and protect delicate thermal runaway materials within the battery. PSA tapes support sustainability by allowing for recycling and repurposing of battery packs at the end of life. By incorporating multiple functions of flame retardance, dielectric resistance, and protection of materials, a single tape product addresses multiple customer needs. So let's take a closer look at each one of these. First, we'll talk about safety. So how do PSA tapes reduce flammability and increase dielectric strength? For reducing flammability, the most common test requirements we see are the UL94V and VTM. VTM testing stands for very thin materials. As shown on the picture on the left, a flame is applied to a cone of material to test it. The flame performance is judged against a 0, 1, or 2 parameter. Now for V, that stands for vertical testing of materials. As shown in the middle picture, typically burning a composite material through its thickness vertically. It's also judged against V0, 1, and 2 parameters. All of our flame-tough materials protect components, not allowing additional fuel sources to be added to the combustion. Now, for boosting dielectric strength, EV battery materials typically have requirements between 2,000 volts and 4,000 volts DC. Dielectric films and fibers can be made of different materials. They can be made from polyester or PETs, polypropylenes or other olefins, as well as ceramic fibers that are also dielectric in nature. A material's dielectric strength is measured using a high pot tester, as shown in the picture on the right. This is how tapes or composite materials breakdown voltage and dielectric strengths are measured. Common test methods that we use are the ASTM D149 for AC current, the ASTM D3755 for DC current, as well as the GBT 1408.1. Avery Dennison offers full high pot testing for all of our single and double coated tapes as a service to our customers. Let's discuss production efficiency. So as I previously mentioned, PSAs enable fast assembly and automation. They can be dispensed automatically and repositioned as needed, helping to improve efficiency and eliminate excessive rework. PSAs form an immediate full strength bond. There's no curing time or drying time needed, which helps improve manufacturing cycle times and throughput. We've also developed special liners to release easily from the adhesive. This helps prevent adhesive failure from delicate materials during the final assembly by the customer. So let's take a look at these automation pictures that are here on your screen. In the first picture, the adhesive tape is being unrolled. It's then presented to the robotic end-of-arm tool. In the second and third pictures, we see the robotic end-of-arm tool with vacuum suction heads on the end, slice the tape to width, and it then picks and places the PSA tape into its final application. And then finally, in the fourth picture, a roller on the side of the robotic end-of-arm tool rolls over the tape, applying the correct amount of pressure for adhesive bonding. For durability and sustainability within the battery pack, Avery Dennison tapes have several advantages. For durability, using single-coated tapes, thermal runaway materials can be covered using a protective film, or they can be encapsulated in a protective film using a pattern-coated, double-coated adhesive tape. These protect pack materials for the life of the vehicle. Now for sustainability, PSAs are already cross-linked, bonding using the mechanisms that I previously mentioned, and they do not cure. So PSA tape can be removed easily at the battery pack's end of life. This meets recyclability targets set forth by different national standards. The adhesives are reusable and, as I mentioned earlier, repositionable. This reduces waste, increases sustainability, and improves manufacturing throughput. Finally, we mentioned the fifth pain point of functionality earlier. So PSA tapes provide a single solution addressing the multiple needs of safety, productivity, durability, and sustainability. These meet the end goal of functionality across the board. So now that we know a little bit more why PSA tapes are the ideal solution for thermal runaway materials, we can touch on the applications. As Mike Sanders mentioned earlier, governments and OEMs have strict requirements related to thermal runaway. On the governmental level, examples are the European Union UN GTR 20 Phase 2 and the China GB standard regulations. In addition, most OEMs have internal thermal runaway requirements that meet or exceed these government requirements. And within the court of public opinion, many people have seen different news outlets showing incidences of EVs catching fire, and consumers adopting EVs fast still have lingering concerns about safety issues. So of course, OEMs have responded by altering their initial EV designs to make them safer and more robust. OEMs are turning to solutions like micas, ceramics, endothermic fibers, and other composites to protect cells, modules, and packs. During the placement of the PSA tapes within the battery assembly, we're going to discuss where they go. The picture shows 4 common application areas of PSA tape. We see tapes used with different materials that provide protection between cells, and because tapes are so thin, they fit in the very narrow packaging spaces between each cell. This is a common application for very large pouch or prismatic cells. Also, as OEMs move closer to cell-to-pack architecture, we see more proliferation of this. We also see tapes placed between modules to stop module-to-module propagation. And finally, we see tapes used to protect the top cover of the battery pack as the vents of prismatic and cylindrical cells expel superheated gas directly towards the bottom of the top cover. Many of these tape applications are used in conjunction with thermal runaway materials, the micas, ceramics, endothermic fibers, and other composites I previously mentioned. And Elcogen will be discussing their thermal runaway materials here shortly. And in these applications, PSAs can perform permanent bonding of different materials. They can be used as an assembly aid, retaining materials in place during module assembly. The material protection of delicate materials, either being covered or encapsulated in different protective films, while adding the benefit of dielectric protection, which helps prevent arcing and shorting during unforeseeable events, as well as improving the pack range and vehicle range by reducing voltage leaks to negative ground.
All right, thank you, Mike. Great job. So as a reminder for everybody on the webinar here, we do have a Q&A at the end of this session. So if you have questions, please prepare them, and we'll be ready to answer them at the end of the call. So with that, I will turn it over to Melissa. Her company, Elcogen, combines some of the fireproofing materials we've discussed with our pressure-sensitive adhesives to create these functional, practical, easy-to-use materials that OEMs can use to prevent thermal runaway. Melissa?
Thank you, Scott. I'd like to start with a little background, as I realize not everyone knows the Elcogen name yet. Elcogen is a new company created after the October 2021 merger of 2 leading specialty material manufacturers, Unifrex and Lidl. Today, Elcogen is an innovation-driven company focused on battery technologies, filtration media, and specialty insulation materials. Through global reach and breakthrough inventions, we're delivering products that enable the world to reduce fossil fuel consumption, save energy, and live greener. Something that I'm personally excited to see after working in the lithium-ion battery industry these past 6 years is the creation of a dedicated battery group at Elcogen. This brings together the collective products, technology platforms, and resources of both companies to support and enable the EV market and its growth for both interior and exterior cell and pack needs. Now, let's look at how Elcogen battery materials can be used and incorporated into the pack to delay and prevent thermal runaway propagation. Elcogen provides materials that are used both on the inside of the cell as well as being used in applications that are exterior to the cell, both of which help to support improved battery performance and safety. One of Elcogen's newest in-cell battery solutions is SiFab. This is our advanced silicon fiber anode battery technology. SiFab allows cell and pack manufacturers to achieve greater energy densities, faster charges, and longer battery life, not only in electric vehicles and other e-mobility applications, but in consumer electronics as well. It is a scalable, engineered anode technology that provides high capacity and long cycle life. It resists swelling that other silicon anode materials are typically prone to. Another in-cell solution is our Innovian branded separator technology. This is a thermally stable fibrous separator designed for use in lithium-ion batteries. The Innovian separator material is inorganic, and as such, it can resist shrinkage at higher temperatures, as well as promote rapid ion exchange. Let's move on to Elcogen's pack solutions, which we define as exterior to the cell. We have a portfolio of high temperature, lightweight products that are designed to reduce thermal runaway propagation, along with providing mechanical and electrical and thermal protections within the pack. The FireWrap LIB family of products consists of Elcogen's papers, felts, films, and coatings. Each of these solutions are thin and lightweight. Next, we have the FireWrap LIB cell spacers. These also have high temperature resistivities and are electrically and thermally insulating while meeting a variety of compression profiles. In addition to inorganic fibers, Elcogen manufactures synthetic fiber battery solutions as well. For example, there's the Litherm Fireblocker family of products. These are a high temperature fire resistant thermal insulations that are typically used for cell venting management in the pack. Now, not all of Elcogen's battery materials are shown here. We also manufacture high temperature resistant and electrically insulating thermal barriers in the form of boards, 3D shapes, and blankets. We can offer a variety of product forms due to being vertically integrated across a range of fiber and process technology platforms. This really helps to enable a broad offering of technical solutions, while at the same time ensuring long-term supply chain viability, supporting the adoption of these materials and technologies in battery and EV platforms. Now I'll get into an overview of the materials that are specifically used within the battery pack for thermal runaway propagation protection. Depending on application needs, battery pack architecture, and thermal management strategy, Elcogen has a variety of solutions to choose from for the finished piece assembly. These include both standalone materials and composite technologies to meet most performance requirements. Functional layers such as mica, foam, pressure-sensitive adhesives, and different types of films can also be incorporated to further enhance performance and create bespoke solutions. Furthermore, the use of composite structures provides options to decrease the use of heavier weight materials in the pack and replace them with lighter fiber-based solutions. Being vertically integrated, we can control the fiber chemistry, product form, and finished piece shape. This allows us to choose the optimal material properties needed for specific applications. As an example, we manufacture fiber chemistries that can resist temperatures up to 1600 C. Materials and finished parts as thin as 0.15 millimeters thick, and pieces up to 50 millimeters thick are available as well. These solutions are extremely lightweight, with density starting at 127 kilograms per cubic meter and have dielectric strengths up to 20 kilovolts per millimeter. As you can see from the graphic on the right, Elcogen's battery solutions for thermal runaway protection can be used on bus bars, next to the cells, inside and outside the modules, on the pack enclosure, and the lid, including the lid seal. I'll dive into some more details in the upcoming slides. Now I'm going to focus on how Elcogen battery solutions are used in the pack, specifically for applications that are found exterior to the module. The FireWrap LIB and Litherm Fire Blocker product families can each be used for module level protection. They share some overlapping properties, such as being electrically insulating and having low thermal conductivities. However, each offers a different set of advantages. The Litherm Fire Blocker is a really great choice for preventing heat transfer from taking place between one module and its neighbors. At the same time, it can help direct gases to support the venting management strategy. This can serve dual purposes within the pack, helping to keep costs down by avoiding the need for additional materials to support other functions. Both product families also provide protection to the battery lid, pack bottom, and pack walls. Choosing the right material for these applications really depends on the overall footprint, along with when the choice is made within the design timeline. Certainly, if the pack is already designed with thermal runaway protection materials incorporated, there's usually less space to work with. In that case, really thin, high-performance materials will be needed. The FireWrap LIB coatings and films, as well as the thin papers, can really increase safety without taking up a lot of space. One feature that our customers have found value in is the ability of these materials to also provide high-temperature electrical protection in addition to the thermal and fire protections that people usually associate with these materials. Because of these properties, some of our thinnest product forms are either being used or evaluated for use in bus bars, busbar connectors, wiring harnesses, and other pack subcomponents that would call for this level of protection. Both the FireWrap LIB and Litherm Fire Blocker product families can be used to protect venting channels from high heat and erosion during a thermal runaway event. Elcogen also manufactures gasketing materials that can help seal the lid, as well as formed materials for aerodynamic and acoustic insulation. For many of these applications, pressure-sensitive adhesives add functional benefits that create tailor-made solutions. One of the main benefits is ease of installation of the part, as the adhesives enable a peel and stick type of application. Pressure-sensitive adhesives and tapes can also improve automatic equipment handleability and improve recyclability at the end of life when an easy part removal is needed. Switching over to applications that are inside the module, I'll start at the exterior of the cell. This is one area that greatly benefits from having high temperature, thermally, and electrically insulating protection. The FireWrap LIB product family can be used in between both prismatic and pouch cells to stop or delay the propagation of thermal runaway from cell to cell. It's important to use materials that can both meet thermal and electrical requirements while providing the necessary mechanical performance to allow the pack to perform optimally during everyday use. There are materials within the FireWrap LIB product lines that can support these competing needs by balancing the safety with performance. At times, pressure-sensitive adhesives combined with different types of films can be needed for these applications. Using these materials can help improve overall cleanliness of the part. Typically, cleanliness requirements can be met with adding 1 or 2 additional single or double-sided pressure-sensitive adhesive films and tapes. This can often eliminate the need to fully encapsulate when cleanliness requirements are in place. Another performance feature customers prefer when using pressure-sensitive adhesives is the addition of an easy release liner, so that the bond of the liner is not stronger than the bond of the adhesive to the thermal runaway protection material or part. As Mike Van Herentz mentioned, this helps prevent any damage to the fiber, avoiding waste and possible rework. Cylindrical cells will also benefit from these types of protections, although the application and implementation strategy will be different. When working with cylindrical cells, groups of cells can be isolated from each other to help stop or delay thermal runaway propagation. Typically, only Elcogen's thinnest and lightest product forms are used for these applications, as space is limited and OEMs are trying to decrease consumers' range anxiety. These same types of materials can also be used for both module, side plate, and end plate thermal runaway protection needs. They can be used for protections on the top or the bottom of the module, particularly if the modules have a stacked architecture. With an expanded manufacturing footprint of over 60 locations, we're bringing together a fresh slate of exciting technologies and opening doors to new opportunities. I think no matter what the application is in the pack, if a high temperature, thermal, and electrically insulating solution is needed, along with having a thin and lightweight profile, there's a good chance that Elcogen can help OEMs meet their safety and performance objectives.
All right, thank you, Melissa. That was very insightful. So now let's hear from Mike Sanders as he reviews the trends in EV battery marketplace and its implications for battery pack design. Mike?
Thank you, Scott. The rechargeable battery market has gotten huge. It's $116 billion as of 2021. It's made up of a lot of different types of technology. Today we talked a lot about lithium ion and lithium ion battery applications in electric vehicles. But one thing people need to keep in mind is a lot of these are also made into packs and into vehicles in different forms. So they also create opportunities for these types of materials in a whole variety of different markets. As you can see, there are many markets that are driving the overall growth of the rechargeable battery market. Automotive is certainly one of the largest now between the automotive piece and the starter battery piece, but we also have industrial applications, power tools, portable electronics, and various other applications as we move closer and closer to the electrification of everything. As we look at just the lithium ion battery marketplace, it's a $74 billion marketplace worldwide. Substantial growth in automotive was first started in China, and we saw China take a very strong lead in auto and e-bus in China. But now we've seen where the auto e-bus excluding China has actually gotten larger than the starting point for China, making this truly a global opportunity and a global focus for activities. And as you can see, the other applications are also starting to get substantially large, which brings a level of innovation and a level of opportunities for a whole variety of type of packs. As we look at where this is going through 2030, the market becomes extremely huge. It moves basically still based on the two main drivers, the electric vehicle and buses in both China and the rest of the world. But we also continue to see the other applications continue to drive forward in a very large way. And as you can see, it gets to a huge marketplace of almost $200 billion by 2030, driving it to be a substantial opportunity for pack design, and pack materials.
All right, thank you, Mike. So to wrap this all up, we are all excited about how the EV battery market segment has grown and how it will continue to grow. We all recognize that fire and thermal runaway prevention remains one of the key engineering pain points. Consumers understandably want safety, and regulators are pushing for it. There's tremendous potential for functional materials incorporating pressure-sensitive adhesives to be part of pack solutions throughout the battery pack. And this includes solutions for thermal runaway barrier and for broader fire retardancy. We can help you solve some of the challenges within battery pack design and want to be a partner for those solutions. For both Avery Dennison and Elcogen, partnership means going well beyond offering off-the-shelf products. We've built our businesses on providing customers with turnkey, customized solutions for their EV battery applications. This features collaboration with our subject matter experts and access to our testing capabilities. We collaborate on new product and business opportunity development by providing extensive application engineering support and 3D design support. Our testing capabilities are in our ISO 17025 certified labs include flame and dielectric performance, environmental testing, compression testing and battery cycling simulation, and bulk property testing such as peel, tack, shear, and release testing. I encourage you to contact us directly so that we can discuss your needs and that we can partner to provide you with solutions. On behalf of Melissa and both Mikes, we thank you for attending today. Here again are their contact details, email, LinkedIn, and the respective websites. So let us know if you'd like to follow up with us. But for now, in this webinar, we'll continue on to the Q&A session.
Thank you for the presentation. Now we'll begin the Q&A session, so please submit your questions by clicking the Q&A button on your screen. I see we have a few questions submitted already. If you could begin by reading the question aloud, that would be great.
Okay, I think, thanks, Chris. I think we have our first question here. Aren't aerogel thermal blankets part of solutions set to mitigate thermal propagation and runaway along with ceramic sheets, composites, etc.? And are you offering adhesives for these products? My short answer obviously would be just yes to all that, but I'll go into a little more explanation here. Avery Dennison partners with functional material manufacturers, companies such as Alcogen, with Melissa on the line here today, to test adhesion and flame performance to different products. Aerogels are also one of these solutions, along with other ceramics and micas. We test these to end users' applications, things like bulk property testing, environmental conditioning, temperature, humidity, salt, and then EV-specific applications. UL94 flame testing, dielectric testing, some things that I already mentioned here today. And then we have a full ISO certified laboratory to do all that testing in. So yeah, the Avery Dennison adhesives are meant for bonding these products in their application. And I think, Melissa, you have the next question.
Yep. So the question is, what are the benefits for your customers regarding the recent Unifrax and Lidl merger? So great question. One of the biggest benefits is the ability to leverage each of the former company's specialty material platforms and process technologies, since we are now one bigger company. This really helps to drive innovation, as well as gives our customers access to an even larger global footprint. Ultimately, this enables us to find or to respond faster and move more quickly, while at the same time ensuring supply chain flexibility and continuity. I think Mike Sanders, the next question is for you.
Thank you, Melissa. The next question is, are there any expected changes in the global EV safety regulations? We're starting to see activity now, in addition to what Michael Van Herens talked about earlier and I talked about in China and EU. We're seeing both of them start reviews and activities to potentially tighten the regulations to shorter durations in time, and also becoming more of a standard in the EU. In the US, we're still not seeing additional activity at this time. Michael Van Herens, you're next, I think.
All right, the next question here says, beyond thermal runaway, what applications are you seeing the most demand for? I would say that dielectric films for encapsulation of conductive materials is probably our next most common application, with a third being the bonding of compression pads to cell architectures. On the dielectric side, we see a lot of encapsulation around cooling and chiller plates, flexible bus bars, aluminum module castings, battery housings, and anything else that's conductive in that battery pack. And traditionally, we're doing either the D149 or the D3755 testing for that. With the compression pads, a lot of those are constant force deflection foams that we're bonding. Sometimes they're bonding to different structures within the module, and then sometimes they're bonding directly to things like the prismatic or the pouch cells. So yeah, I think that answers that. Melissa, you want to take the next question?
Thanks, Mike. So the next question is, what are the most common materials currently being used in the pack for thermal runaway protection? Well, I think this probably goes without saying, but certainly the thinnest and the most lightweight materials and solutions are the ones that are most often being used from our portfolio. We are involved in many different applications within the pack, so it can be and often is application specific. The Litherm fire blocker felts are commonly used as thermal barriers and venting gas management assemblies, either at the lid of the pack or from module to module. The fire wrap LIB papers are more commonly found at the cell level, although can also be used in other parts of the pack depending on the architecture and other functional layers that they might be combined with. Some of our newer product lines, such as the fire wrap LIB films and coatings, are being incorporated and evaluated at a much greater rate compared to the prior years. And I think this is really due to the need for ultra thin materials for tight spaces that can be used to help delay the thermal runaway propagation. All of these solutions and materials that we promote are thermally insulating, high temperature resistant, and have thin profiles. However, we are aware of the need by some OEMs and pack manufacturers to utilize solutions that have lower thermal conductivities. Due to these needs, we are expanding our product portfolio to include lower thermal conductivity materials. As such, I am excited to announce that we will be launching a next generation flexible aerogel material for use in electric vehicle battery packs. I can't share too much yet until we actually launch it, but it does have exceptionally low thermal conductivity, superior thermal performance, and it has a reduction in insulation thicknesses compared to competing insulation products. This is our first step into fiber-based aerogel composites, and I would just recommend staying tuned over the next couple of weeks until the press release comes out. Mike Sanders, I think the next question is for you.
Yes, Melissa. The next question we have from a webinar participant is, what is the projected split between pouch, prismatic, and cylindrical cells? Today, we're seeing cylindrical be at about 20%, pouch being roughly 40%, and prismatic being roughly 40%. Our projection through 2030 is for cylindrical to fall slightly to 18%, prismatic to go up to 42, 43%, and the balance being pouch cells. A lot of the choice of what format is being utilized is highly dependent on who your cell supplier is. Mike Van Herens?
Playing virtual hot potato here, Mike. So I'm going to address two questions that came in. The first one was, are you currently supplying PSA to any OEMs, and can you disclose? The short answer is yes, we are supplying to OEMs. I cannot disclose any of that information right now, but we are supplying to OEMs at this time with Avery Dennison tape products. And then as a follow-up to the first question, another question came in here. Following up on the first question, if we are interested in thermal runaway solutions, do we contact Avery Dennison for a combination of Elcogen and tape solutions, or do we contact Elcogen, who then would incorporate any Avery Dennison tape? I would say that either one of those, whether you contact Avery Dennison or if you contact Elcogen, Melissa and I work very closely with one another as from both of our respective companies, and either of us would be able to work together to come up with that solution for your needs. So you can feel free to contact either one of us for that. So Melissa, I don't know, I'll just transition to you and see if you have anything else that you want to add to that question here.
Nope, I think you covered that well, Mike. Certainly reach out to either of us and we can get you on the right track for what you're trying to do. I have another question here. Is it common for PSA and functional material manufacturers to work together on electric vehicle battery pack solutions? So the answer is yes, as I think Mike just alluded to, but it does vary case by case. When we have an adhesive back part and it's needed, sometimes the adhesive requirements such as bond strengths, end of life recyclability, flame retardancy, can get really specific. When these types of requirements arise, it's more common to work more closely with the PSA manufacturer. I think this type of relationships becomes more critical when some of the needs get even more complex. An example of this would be incorporating different adhesives on each side of a double-sided tape, as well as needing customized roll sizing or different adhesive patterns. Additionally, working directly with the adhesive manufacturer allows for quicker turnaround times and faster identification of the optimal PSA system for the finished piece, since they are the subject matter experts and can usually turn around that testing pretty quickly. Mike Sanders, I think you've got the next question.
The next question we have is, are the adoption rates we're seeing in automotive comparable to other forms of transportation? We're actually seeing adoption in other forms of transportation at a little higher rate than what we're seeing in automotive. And that's due to clearly identified safety risk, especially in mass transportation and other areas. And also the ease of implementation there is much easier than doing it in a full vehicle platform. So the adoption rates and timing typically are faster in a lot of the smaller applications. Mike Van Herens?
Okay, thanks, Mike. Had a question come in here. I'm going to ad-lib it here. Is tape a good option for inside the EV module cold plate with irregular shape? Really, in this, to answer this question, it's really not what we're showing here today with our thermal runaway products necessarily, but on our conformable dielectric portfolio of products, we have received the voice of customer over the last year to year and a half from our customers, looking for irregular shape, or looking for dielectric solutions for irregular shapes. And we have developed some custom constructions, which we refer to as our Generation 2 product line of our dielectrics, to be able to encompass and encapsulate things such as cold plates, because that was actually one of the primary applications we found that required a much more conformable material to wrap around the edges, the radii, and then the quick connections within that. So we do have those materials, and if you want to, send me a message, I can be happy to go into more detail. Melissa, you want to take the next question?
Sure. So we have a question. What is the total thickness between cells? Must the cell spacer product be for stopping cell-to-cell propagation? So for this, it really does depend on the pack design, the types of cell used, and what the overall thermal management strategy is. Different packs can incorporate active cooling, passive cooling systems, and have a complex thermal management strategy depending on the design. So unfortunately, there is no hard and fast answer. It just varies by pack. Certainly, we've supplied materials as low as 1 millimeter into these applications, going up to like 6 to 7 millimeters. It just depends on the application.
The next question that we have is, outside of automotive and transportation, what other product segments are growing rapidly with battery usage? We had an interesting session a few weeks ago where one of the industry leaders in producing battery packs and systems used the term of electrification of everything. And that's really what we're starting to see now, is the commercial industrial applications and the various applications in industry are continuing to drive towards electrification. What's important about those and safety materials like we've talked about today is a lot of those applications have very demanding application use and very demanding charge cycles, which have a tendency of building up heat and creating challenges for the various system dynamics. But those can also be areas that are good experimental grounds for really driving into larger automotive and transportation. Michael?
Okay. I got a two-part question that came in here. First part was, how do PSAs perform over the period of time, or over a period of time, since it's in a thermal environment? Actually, from a pressure-sensitive adhesive standpoint, the temperatures inside the battery pack are actually very low compared against some of the service temperatures we see in other applications. So that has never been an issue during any of our thermal cycle testing, key life testing of our products in that thermal environment. We don't see really anything above 60, 80 degrees centigrade under typical operating conditions. And most of even our acrylic products are usually good. I would say up to 100, trying to do conversions here in my head to centigrade here, but about 130 degrees, 140 degrees centigrade. Second part is, what is the density of a PSA? The pressure sensitive adhesives we use are combinations of carriers and adhesives, so there isn't a specific answer to this. They are more dense than water, though, from a specific gravity standpoint. So I would typically say they're about 1.2 to 1.4 specific gravity. So I guess that's the short answer to that question. Melissa, you want to take the next one?
Sure. The question is, how does Elcogen work with OEMs and pack manufacturers regarding their application needs? So we prefer to work directly with the OEMs and pack manufacturers, and ideally we would be meeting with the design and material engineers as early on as we can during that design process, or when they're creating the toolkit of materials. I think, as many in the industry know, this is a rapidly changing and evolving market, and it's best to be in close communication with the engineering teams for a variety of reasons. The first being that we need to really understand the design needs as well as the importance of each of the requirements. This enables us to put forth the solution that will best meet the needs of the pack without over or under engineering it. We have also found it valuable to understand our customers' test methods and to run those same tests internally as we evaluate the different solutions that we can offer. That way, there's no surprises on either side when it comes time for implementation. And lastly, when we are in close contact with the OEM or pack manufacturer, we're able to respond to changes with more speed and agility. Sometimes we need to pivot to a different material technology or solution depending on new testing or learnings from our customers. Having that close and regular contact really helps to achieve the most successful outcome. Mike?
The next question we have is, what impact has the political landscape had on the EV space? And did OEMs have to react, or were they already planning for this growth? The initial political landscape was really driven by CO2 regulation, roughly starting about 10 years ago, might even been a little bit longer than that, with a roadmap that was going to drive the change from internal combustion engines to electric vehicles. Now what we're seeing, which started about 6 to 7 years ago in Europe, is the regionalization and the activity to drive a regional value chain in Europe and now in North America that's driving substantial growth in both regions and substantial growth in the number of vehicles that are being launched. So I'd say they were planning for it for a long time. Moving it from planning to reality is really where we are in the marketplace today. Michael?
All right. The next one I see, based on your thermal runaway films offering, how do you decide which one is the best for the application? I would say, first we look at the application service temperature that it's going to see. Obviously, I kind of covered part of that in the last question about the service temperatures we see in this specific space of 68 degrees centigrade, maybe a high OEM requirement of 100 degrees centigrade. We see if there's a dielectric strength requirement. If so, then we're going to most likely put some form of carrier on there. And then finally, we look at the flammability requirements, whether it needs to be a UL 94 rating, whether it needs to be an FMVSS 302 rating if it's an automotive application. If it is a UL 94 application, what level of UL 94 does it need to be from a 0, 1, or 2 scale? And is the tape going to be tested as a VTM thin material, like I showed that illustration of the cone, or is it going to be tested as a composite? So these all are what we typically use to make a decision on what thermal runaway film we're going to be using. Melissa?
So we have a question here. It says, Melissa, I think you were talking about formable products with a max thickness of 50 millimeters. Would Elcogen do the forming process, or would you supply the basic material and we could do the forming process? What does the forming process look like? Is it more similar to injection molding process, or is it some type of press forming? So we do form our own finished pieces and parts. The Technology will depending on what the base material is and what the ultimate finished product form is. I wouldn't say that it's similar to injection molding, but we can heat press parts as well as use some different types of technologies that involve vacuum forming. Mike?
Yeah, the last question that I have is when do you envision that we'll have more EVs on the road than internal combustion engines? We're now seeing multiple countries regulate the change from internal combustion engines in passenger cars to electric vehicles, and we're starting to see more line up for about the 2035 timeframe. But the market will be ready basically to get to about 50% by about 2035, might be 2038, depending on capitalization and the rate that it actually takes place in different regions.
Well, thanks, Mike. And thank you everyone for joining us here today. On behalf of myself, Melissa and Michael Sanders here, if you have any further questions, our contact information, hopefully we're able to grab that, and then it will also be in the PDF that you can download. I just want to thank everyone for attending today, and you have a great day. Thank you.
Great. Thanks for the presentation, and thanks everyone for the excellent questions. It was a great discussion. The recording of this presentation will be available to view on demand on our website. Also, the link to download the slides will be there, and a form to submit some more questions to the speakers if you have them. So thanks again, everyone.
Thank you. Have a good day.
Thank you.
Bye-bye.